well, thank you. It's an honor to be here for GIS Day, considering I'm not a geographer. So I think it's a tribute to how far GIS has come. You have the political economists up here talking to you all about GIS. So this is a wind farm in Tehachapi. This is kind of California's Saudi Arabia wind, right? And so you can see all the wind turbines. So this is a pretty story until you start hearing the rest of the story, which is, you've got to get all that electricity to people that flip their switches and turn on their computers. There aren't that many people that live in Tehachapi, right? So you have to build a big system, a big investment to get it down to LA. So here's the map. This is Tehachapi up here, and here's the power line that comes down through the desert over the hills to grandmother's house down here. And then this is the area that we were really interested in when we picked this project. This is the wealthy older white community of Chino Hills. And so this is Pasadena, just so you have reference. But anyway, so you need this power line to get the power from all those wind turbines down into LA where it can be used, right? Well, this power line hasn't been built. It's been built, part of it's been built over the hills, but they can't connect it to the substation because of a long legal challenge and then a long regulatory challenge that just recently got resolved. And the PUC, the Public Utilities Commission, in 2009 said, hey, you guys can build it through here. And then 2 years later, they reversed themselves after the city of Chino Hills and the rich white people said, we don't want it through our neighborhood. And they recently just ordered Edison to put it underground at a cost of, well, we're not sure. The initial estimates were like $400 million. Right? So that's money that you all would be paying, that $400 million, to keep the residents of Chino Hills from having this power line through the backyard. Now, granted, you have to understand the power line is 200 feet tall, and it's on a right-of-way that's 150 feet wide. And so if the power line tips, which they tend not to do, but if it did, it would fall, it's roughly, whatever that is, 125 feet into the houses, right? So the right-of-way wasn't adequate, so it was a bad decision to begin with. But that's kind of sets up this issue, right? Because we ended up choosing this project because it was such a great case study, and then while we were analyzing it, they reversed themselves with all these politics. So anyway, it kind of made our case, and now that we're talking to Edison about using this model for future projects so they don't get blindsided like they did with this one. Okay, so this falls into the kind of classic social dilemma, right? So, we all need electricity to power our lights, but if you live next to the power line, those costs for everybody getting that public good, you have to pay for the public good. Those benefits are concentrated when people live next to the power line, live next to the power plant, next to the fracking well, whatever, right? So you hear about this is NIMBY. It's also Nope, not on planet Earth. Banana, build absolutely nothing anywhere near anything. And then the really boring academic term, locally unwanted land use. So that's what we use because it's pejorative to call somebody a NIMBY. Right? But I mean, unfortunately, that's what happens. That's the project for the proponents, the utilities, infrastructure companies. That's how they think about these. The citizens have legitimate concerns, right? I went out and interviewed the citizens from one of the citizens of Chino Hills, and she said that Edison told her that she would have to ground her fence because it would arc because the power line was so close, and that her pool would be usable. So, I mean, that's a legitimate concern, right? So we've looked at all of this, and we did a big lit review, and we decided, hey, it's not the citizen attitudes that are driving this, because a lot of academic literature says, hey, you have to understand the citizen perception of these power lines or these wind farms or, fill in the blank, right? And we're like, no, this is not a citizen attitude thing. It's about how citizens get out and advocate their interests, right? Or it's then how well are those interests heard by the people making the decisions, right? So you need to understand not only the citizen, the community attributes, and then the institutional setting, right? And so being a political economist, we're all about institutions. So we take a more interdisciplinary approach, and that's embedded in our modeling too. So we take things from social psychology, from economics, from public administration, we take these kind of best of class theories and integrate them into our modeling design to try to provide this edge, to try to provide some decision support. So we've been working on this now for 3 years. We got a grant from Edison to do it originally. And what the model in a nutshell does is it takes GIS data, right, which you all are familiar with, and we have different layers of GIS data. So we have census data that's spatially explicit. Then we add in the project engineering data. But the big value add, there's a couple of big value adds, but the one I'm going to talk most about today is the agent-based modeling. So we have a model of how citizens interact to oppose a project, right? And then we have these institutional layers, these bargaining layers. So what we're doing is we're adding these social and political layers on top of what kind of thing that you're already familiar with, right? And so if you think about it that way, it's pretty tractable. You can get down into the weeds in terms of what how the model is built. And okay, so what is a decision support system? Well, fortunately, it's somewhat self-descriptive, right? We're just trying to help decision makers do their job a little bit better, right? But the thing about decision support systems is they need to be kind of generalizable across different cases, right? So hopefully what we've designed here is that, we can apply this model to Chino Hills, we can apply it to a solar project out in the desert, we can apply it to a pipeline project, because the underlying dynamics are the same, right? Okay, I think I already gave away that secret finding. So the idea is that in terms of specifics on what these compromises that can be made, you can change the project route, you can change the disruption of the project. They're going to underground this project to make it less disruptive. And you can find out, I'll talk a little bit more about this, but like who the key stakeholders are, right? So it's one thing to say, well, here's how the citizens are going to react, right? But then, and I'll talk a little bit more about it, we also have the stakeholders and the decision makers in the model, right? So say Tom's he's an environmentalist, that's not much of a stretch. And then Mike's a pro-development guy, right? So if you think about it on a 0 to 100 scale, they're at the opposite ends, right? So there doesn't seem to be any zone of compromise, right? And then we bring in Javier, and he's what we call the median voter, right? He's right at a 50, right? So they're both courting him. They're trying to get him to get it over in their position, right? And then, so they might, if Tom's really aggressive, he might be able to pull over to a 70, get his ruling, get his decision, right? So we can simulate not only the citizens, we can also simulate the stakeholders, right? So we know that Tom has a mean position of 100. Well, what happens if we vary that? Right? Who do we have to bring in to get to that 70? Right? How do we move from a 50 to a 70 by bringing in new stakeholders? Right? So these are all things that we can simulate beforehand. So we're not only simulating the citizens and how they get upset, but the stakeholders and how they bargain, and ultimately the regulators or the decision makers too. Okay, so what's an agent-based model? Well, we could develop an agent-based model of everybody in this room, right? So the agents would be students who are here for the food, maybe to meet somebody, so those would be their objective functions. We have the faculty here who are here because maybe they're interested in the topic, so they would have some objective of learning, perhaps. You would have the staff here, who are here because they're getting paid to. So, but these people are going to interact, right? And they have they'll interact and exchange something. Could be information. In other agent-based models, is money, right? But the really beautiful thing about GIS is we could put everybody in a grid, right? Give everybody a lat long in the room. And we could say, oh, well, Mike and Tom are more likely to interact because they're sitting next to each other. So Tom's much less likely to interact with somebody in the back corner. So in terms of, and this is one of the things that's driving our model, is this attitude diffusion, right? And so attitudes can be diffused spatially. Now, I know everybody will say, well, what about Facebook or Twitter? Well, okay, yeah, that's great. But, you're not always tweeting about this kind of stuff. And the empirical research shows that, in fact, most communications is done on a geographic basis. You talk to your neighbor, your roommate, your next door neighbor, whatever. And then there's this kind of random component too, right? That you might run into somebody in a park or whatever. But usually it's like kids' soccer games, that kind of thing. So that's the fundamental. That's fundamentally what agents do. Agent-based models do. And the beautiful thing about agent-based models, as opposed to like a microeconomic model or some kind of an equation-based model, is we can introduce all kinds of heterogeneity, right? So like we've already got these different agents. We got student agents, we got teacher agents, we got staff agents. Maybe we have complete stranger agents, right? That they're here just because they smelled the food outside and came in. But we can put that in the model, right? And so they can interact with these other agents, and as a result of these local interactions, some phenomena could come out, right? So we have stakeholders. That's homeowners, homeowner associations, governments, residents, environmental groups, the project sponsor, which in this case is Southern California. Put them into the model. We give them attributes. So in our model, we call it power, but that's essentially just how much money you make and how much education you have, because we think that those are the things that drive your advocacy. Right? Your knowledge of the project, how much spare time you have to engage in advocacy, how much money you have to hire a lawyer. Right? God forbid I'm not advocating for that. Okay, and then we let these agents interact, right? So you all are talking to each other. Maybe you met somebody new over at the food line, right? So you interacted, hopefully something good came out of that. Maybe you brown-nosed your professor, let him know you were here, you didn't get a good grade. Yes, he sometimes not. So see, right there, I generated what we call face validity, right? So, when you're presenting, it's never easy to present these models, right? Because people are like, what the heck's an agent-based model, and why should I care? So what you want to do is you want to let them know that agent is them, right? That's you. Right? We probably can't relate to being a public utilities commissioner, right? Or the head of the Sierra Club or whatever, right? But you get the same. It's the same concept, right? That agents have this objective function or whatever it is, and they interact, and as a result of this interaction, something either good or bad happens, right? Or maybe neutral. And so that's the behavior of it. Okay, so what does this have to do with GIS? Well, a lot, right? And what we're trying to do here is develop this decision support model to help folks make better decisions. And so it's really hard to make decision support models without some representation of real life. And if you can think of a way to represent real life without GIS data, I'm really happy to listen. But it seems to me that GIS is really a necessary condition, right? And so GIS is fundamental to our model. And why is that? Well, we're trying to explain this macro level behavior, right? Well, macro level behavior comes from these local interactions, right? And so you need to have an accurate representation of the barriers and the opportunities that each agent faces in their little world. Right? So if I live in a high population density, like if I'm sitting in the middle of the room, I have a lot more people to talk to than if I'm sitting over here, right? And that comes from GIS. And the other barrier, you think about this in terms of species movement, right? And so one of the big barriers to species movement is the built environment. So it could be a freeway or a border fence or whatever it is, right? Same thing with humans. Is it, you live on the right side of the tracks or you live on the wrong side of the tracks? That's the old story. I don't know if there's the right side or the wrong side. In Claremont, there's the 10. You live on the right side of the 10. Okay, so here's an example of our GIS data. And so you can see there's a lot of variation in color. Well, what's the color? Well, first let me tell you, this is the power line. You saw that, I think, before. This is maybe a little clearer example. It splits in two. It comes through Pasadena, and this is east of Pasadena. And then this is like down here, I think, is Monte. I don't know. And anyway, here's Chino Hills, right? So what's the heat map? Well, this is normalized power. So we take education, multiplied times this is household education times household income, and we normalize it against the highest value, right? So you can see that the light colored areas are low power, the blue areas are high power. So from our priors, we would expect a lot of opposition through Chino Hills. We'd also expect quite a bit of opposition through Pasadena. And then you can think about the size of the block group as the population density, right? So the little tiny parcels in here there's a lot of people living there, and in San Gabriel Mountains, there's hardly anybody living there. That's one block group. So there's a lot of information that comes just from the census data for our model. So the other thing we're looking to add to the model is a variable called place attachment, which comes from social psychology as well. And it basically means that if you have grown up in a place, then that place is more part of your identity, right? And so we're going to put that in the model as normalized years of residency and home ownership. So there's a whole, and so these are really parsimonious indicators, right? So we're saying that income captures a lot of other things too, like a thing called power, as we call it, this thing called self-efficacy, right? So that's a concept of your ability to affect change. And that's one of the biggest predictors of participation in these kind of events, as is your network, right? So economists missed out on a lot of things for a lot of years. They're starting to figure out that it's not, people don't just live and act in isolation. We're really dependent on what our peers do. Right? So these peer effects are a big thing in microeconomics now. Right? And so that's somewhat captured in our model too, in the way that we deal with the way that the agents interact. Okay, so I probably don't have to tell you guys about the importance of citizen engagement. This is, kind of one of the core kind of mythologies about America, right? That this participatory democracy and citizen engagement leads to better outcomes. And there's a pretty large literature that supports that. So the answer is yes, it certainly can. And that's something that we've been aware of since the get-go. And I'm not sure that we've fully figured out how to deal with that. But I'll talk more about that in a second, in the sense that part of what we want to do is engage the right type of client. So our idea behind this is that instead of ramrodding these projects through, we want this to be an opportunity for the project proponent to think about these issues, do these simulations beforehand, and identify consensuses or compromises that they can make earlier in the process, right? And so it doesn't get to this legalistic, my lawyer is better than your lawyer. And outright vandalism and theft. That's one of the things that has been occurring in Chino Hills, at least prior to Chino Hills getting their way, was they were stealing and tearing up Edison's equipment because they were so upset, right? And so, in this country, we're really lucky that that's like the worst thing that happens, right? In China and a lot of other countries that don't have the kind of processes that we have for conflict resolution, there would be people dying and a lot worse vandalism. We have 3 different modules. We have the citizen module that I somewhat described to you, right, which is this attitude diffusion model about how do citizens come to oppose projects, how do they influence each other, right? And then at the end of that, of those citizen interactions, the citizens can decide whether to join a community-based organization, right? And this is basically a grassroots organization that opposes the project, or they can't support it, but typically opposes the project, right? And so at the output of the citizen module, these community-based organizations go into this stakeholder bargaining module, right? And maybe that sounds like a big deal, but it's really just basic kind of, it comes from spatial bargaining, right? So you think about a 0 being pro-project, 100 being anti-project. We place everybody on that continuum, right? This comes from survey data. And we give them an influence score, right? So each actor gets their preference and their power, Right? They have their own power. Right? And then they bargain. And in this case, they use non-cooperative game theory because you assume this is a zero-sum game, right? That you pull and haul, right? There's no, in a sense, there's no win-win in the bargaining game. So the stakeholders do this. The community-based organizations influence them. I'll show you that in a minute. And then towards the end, the regulators come in and they bargain with the stakeholders for a while, and then they kick the stakeholders out and they bargain amongst themselves and make a decision. Procedural justice. So this is somewhat akin to trust, but it's essentially, how well do citizens feel that they're being heard in the process, right? So this was a big issue in Chino Hills, right? And you can think about this from you guys familiar with principal agent theory? Who's heard of principal agent theory? So this comes out of econ, I guess. It basically says that in any relationship, there's a principal, which is, you can think about this in terms of the Public Utilities Commission. In terms of the principal being the citizens, right? And then there's an agent. An agent works for the principal. And the problem is, the agent can do one of two things. The agent can have more information than the principal. They can use that information as leverage or as power to do what they want. And the second thing is they can do what they want, right? It's called goal asymmetry. So if you're an agent, you can shirk, you can surf your iPhone, you can tweet, you can do whatever at work, and unless your principal, in this case your boss, has some software, keystroke monitoring software, which they probably do, just in case you didn't know. Just FYI, that's a lot more widespread than you think, even at universities. Then the agent has the opportunity to pursue their own goals and do things, right? And so the problem at Chino Hills was that the Public Utilities Commission was not only supposed to protect the citizens of Chino Hills and other citizens, right? They were the agency that was supposed to be meeting all these renewable energy goals, and they're the ones who approved all these projects and the Hatchet, and they're the ones that needed this power line to get built so that the juice could get down to the state. So in our model, proximity to the power line or the project drives so much of the modeling outcomes, right? And this is consistent with the empirical literature, including a survey that we did at Chino Hills. But the salience or this importance, I mean, if you don't, you might have strong opinions about something, but if it's way down on your list of priorities, you're not going to take the time to write a letter or email or call or whatever, right? So proximity, and this is another kind of spatial component, right? And that's why the population density is so important. So we don't have a lot of pro-development CBOs because people that would be pro-development, it's really way down on the list of priorities. They don't take the time. Okay, and then this is the dashboard. So that's the windshield. This is the dashboard, right? And so here are the preferences of the citizens. Here's regulator preferences. This is salient preferences, so it's how much they care in terms of preference. Stakeholder preferences and regulator preferences. And then these are basically monitoring the different stakeholders and monitoring different aspects of the citizen group. And we do this partly to validate the model, so we can track all this stuff and make sure the model's not blowing up and we don't know about it. So you can export every one of these things into Excel at every time step, right? So we run the model for up to 25 time steps, and each one of these things is captured, each one of these variables. So it helps us do the process or kind of validate the model. So I hope that demo was worth it. So we had an earlier question about the validity, right? How do we know if this thing is actually working, right? Because you can't. It's not like you can lift up the hood and see if all the cylinders are running or if the fuel injector is working or whatever, right? Which in these cars nowadays, I can't tell it during video or whatever. All right, so what we did is we geolocated all of the citizens that made comments. That's the beauty of these environmental impact processes. All this data is public, right? So we got all the data from the website. We plotted along the power line. You think citizens, what do you think drives citizen opposition? Is it proximity to the power line, or is it their age? No, it's proximity to the power line. This simulation, you guys are right now. But in terms of the decision support model, utilities and project sponsors are the potential biggest users of it. Government agencies could use it. Project opponents could use it as well. I mean, if a government agency hired us, then we could make the findings available to both proponents and opponents. That would be, well, there's a lot of different applications. One thing we're thinking of doing is extending this to include transportation. So this is this is Google Maps, but essentially we would just load in OpenStreetMaps, and then we could take data from Google or other traffic flow sources to simulate the impact of a new facility in a location, right? So there's pretty well accepted methodologies for like air quality emissions, and in addition to the traffic count kind of a thing. But traffic count would be essentially our disruption. So you could see if you put a target in here, right, what would happen to traffic on Foothill Boulevard, this is Chrome, and what would happen to particulate emissions and other greenhouse gas emissions. Okay, so basically what's the bottom line? Well, thanks to GIS and census data, we can say that the citizen proximity and these attributes of the citizens are key drivers of opposition to these projects. Then hopefully this can help increase efficiencies, both reducing the cost of these projects as well as helping communities improve the quality of life. Not every community has $4 million to oppose these projects. That's how much Chino Hill spent to fight the power line. And so the idea is that a simple tool like this, well, seemingly simple, can be used to help reduce its costs and improve social justice outcomes. And then really all we're doing here is adding these new layers on top of the spatial data, right? And that these social and political layers can be simulated. This isn't rocket science. All this stuff's been around for decades, right? But by combining them, you can really leverage the different data sources and the different modeling approaches and create, we think anyway, a significant source of value for decision making.